doing Good Day Geometry. We are back with PO16 looking at another proof. The class has spoken and they decided on, well, one person decided on, this bottom left one here, where we've got this figure with the angles and the numbers and the things. And it says, given that the measure of angle 1 is equal to the measure of angle 3, prove that the measure of angle EBA is equal to the measure of angle DBC. So let's identify some things first here, okay? Measurement angle 1, we see that there, it's marked with the 1. Measurement angle 3, we got that there. They're marked congruent in the figure, and our given statement is that they're equal. So all is swell there. And we have to prove that EBA is equal to DBC. So I'm going to underline EBA, and EBA goes from point E down to B and out to A. Okay? You can mark this on your page if you want to. You don't have to. You can kind of see it, but that's angle EBA. And we want to prove that that is equal to the measure of DBC, which starts at point D, goes down to B, and then goes up through C. Okay? Now, in your head, take a look at what we know. Take a look at what we can conclude. Does it make sense that those two angles are equal? Just before we start.
Yeah.
Is it logical that they are? Why? Just in your own words. Don't worry about postulates or theorems. Just in your own words, why does it make sense to you that those two angles are going to be equal? Caleb.
Because there's the two like congruent angle lines.
Okay, that's for angle 1 and angle 3 only. But what about EBA? I didn't know that. What about EBA and DBC? Does it make sense that those two angles, the one in red and the one in blue, are going to be equal? Joe?
It makes sense.
Because?
They have those markings on each side.
Yes. So that's for angle 1 and angle 3 only. Angle EBA is more than just angle 3. It's angle...
And the top. The very top.
The very top. Up here?
Yep.
What does that do to anything?
It's another symbol.
It is not. It's just the top of the phaser.
Oh, can I?
Another thing of it. Michael.
It's because it looks like it.
Oh, it looks like it. Okay. Drew.
Well, EVA and DBC, they both use 2.
Okay. So 2 is the common angle there, right? Right? We know that angles 1 and 3 are congruent, and both angles have 1 or 3, and both angles have angle 2. Right? So it makes sense that they're congruent because they're basically made up of the same angles. 1 and 3 are equal already, and they both have angle 2, which is the same. Okay? So kind of keep that in mind as we work through the proof here. We're going to have our statements on the left. I'm going to leave myself plenty of room to write here because I normally cut myself short. Our reasons on the right. And our first statement is going to be the measure of angle 1 is equal to the measure of angle 3. Why can I say that? Why can I say that? Blake?
Because it was given as a gift.
Given as a gift, right. The spirit of Christmas. Here's your gift. Okay. Remember, your first reason is always given or marked. If we just had the diagram, the proving statement, but it's marked in the figure that angle 1 and angle 3 are equal, we can go that route too. We can say it's marked. Okay. Who remembers what the other piece of advice that I gave last week for doing proofs? It's, what do we know? What can we conclude? What was the other piece of advice? Anyone remember? My words of wisdom have been forgotten by all. Okay. It was if we need to prove that EBA is equal to DBC, we've got to invite them to the party, right? We have to have them as part of the proof. So unless there's something else we can say about angles 1 and 3, what can we say about EBA? Let's introduce EBA to the party. What do we know about angle EBA? Do you know?
Measure 3 and measure 2 equal EBA.
Ooh,
EBA.
excellent. Yes. The only thing we really know about EBA is that the measure of angle 2 plus the measure of angle 3 equal the measure of angle EBA. I told you I cut myself short. I still did it. Right? What is EBA? What can we say about that angle? We can say that it's made up of angles 2 and 3. Right? The sum of angle 2 plus, or the measure of angle 2 plus the measure of angle 3 equals the measure of angle EBA. And what allows us to say that? What allows us to say that the sum of two angles will equal the whole angle? It's almost like we're, adding angles together or something. Joey? The angle addition postulate. The angle addition postulate says that if you got two angles that make up a larger angle, their sums will equal the sum of the larger angle. So measure of angle 2 plus angle 3 equals measure of angle EBA. Let's invite angle DBC to the party. What do we know about DBC? Drew.
The measure of angle 1 plus the measure of angle 2 equals DBC.
Okay, the measure of angle 1 plus the measure of angle 2 equals DBC. I want to reverse that for a strategic reason you may see shortly. But I did that so I can line up my angle 2's. Right? Angle 2 is a part of each of these. And I had them line up vertically just so I can recognize that, just so I can see it. And it's going to come into play in a little bit here. Okay? What DBC? Measure of angle 2 plus the measure of angle 1 equals DBC. And why is that? Blake? It's also the angle addition postulate, which you can abbreviate if you want to be the AAP. I'm going to do it just because of space here and because it's the same reason that we have above. And the angle addition postulate. Okay. Now our goal is, right, what we've got now, we have two equations. One of them equals EBA, the other one equals DBC, and we essentially want to get that broken down into one equation where EBA is alone on one side and DBC is alone on the other side, showing that they are equal to each other. This is similar to the one we did up above it. Anyone see what we can do here? Have an idea? Joey.
So you could do substitution to sub out 3 to 1.
So we already know that angle 1 is equal to angle 3. That was established. That was given. So I'm going to take my second equation here. I'm going to rewrite it as my step 4. But instead of angle 3, what do you think I'm going to put in there? Instead of angle 2 plus angle 3 equals EBA, I want to write angle 2 plus angle 1 equals EBA. Why am I able to do that? Why am I able to replace angle 3 with angle 1? William? Because they're the same. What's my reason I'm going to write over on my formal proof here? Drew? Substitution. Right? Whenever you replace a value or substitute a value in, okay? But William, you're exactly right. If angle 1 is equal to angle 3, then it's going to be the same thing either way. So now, I've established that my two equations now, right, because I rewrote step 2 and step 4. So my two equations that I'm working with now are angle 2 plus angle 1 equals DBC, and angle 2 plus angle 1 equals EBA. And I want to say that EBA is equal to DBC. The transitive property, exactly. Yeah. I've got EBA and DBC both equal the same thing. Right? And if two different things are equal to the same thing, they've got to be equal to each other. You know? We've talked about transitive before, and we said it's going to be a really big one. If you've got something like, 7, this is totally separate, so write it down if you want to, don't if you don't. If you have 7 equals 3 plus 4, and 7 equals 5 plus 2, well, okay, 7 is 3 plus 4, and 7 is 5 plus 2, therefore, 3 plus 4 must be equal to 5 plus 2. Right? That's essentially what the transitive property says. And we can see that, oh yeah, that makes perfect sense, right? They all equal 7. It's a little bit more abstract when it's with angles and things like that, but that's basically what's going on here. Okay? So my fifth step can be the measure of angle EBA is equal to the measure of angle DBC because of the transitive property. Questions on this? When I was learning proofs for the first time, personally, I always felt like when it was all done, it was like, oh yeah, okay. But then ask me to do it myself, and it's like, I don't know where I'm supposed to start. Okay. So if you're feeling confident when you see it, but then you have to do it your own, it's everything is all of a sudden lost. I don't think that's a very uncommon thing to feel. I think it's pretty normal. So, but any questions that you have? Okay, let's look at the one right next to it here. Okay, we've got a segment AB, and it says M is the midpoint of segment AB, and we have to prove that AM is half the distance of AB. Okay, given that M is the midpoint of segment AB, prove that AM is half the distance of AB. All right, let's start our chart. Statements, reasons. What do we do first? Step 1. There should be 25 hands in the air right now for what step 1 is. Because this is almost like it's given to you. Peter?
M is the midpoint of segment AB.
Yeah, why, Peter?
Because it's given.
Yes. M is the midpoint of segment AB because it is given to us. We are told that. M is the midpoint of segment AB because it is given. Ready for some more words of wisdom from Mr. Schultz? My first words of wisdom didn't go so well over the weekend, apparently. Maybe whenever you've got a vocab word as in your given statement, your next step should be to define it. Remember, we're using definitions, properties, postulates, theorems. When you've got a vocab word, and you can tell the difference between a vocab word, right? There's no vocabulary here with angle 1 and angle 3. I think in the first one, we were told they were vertical angles. We defined what a vertical angle was. We said, what does that mean if it's a vertical angle? So you see this word midpoint here. Your next step is going to be, well, what does midpoint mean? The fact that it's a midpoint means what? Let's define it, Caleb.
It's the middle point of the segment. It's right in the middle of the segment.
Okay, now that's way too long for me to write, that M is the middle of the segment here. How can I say the same thing?
M equals 1/2 of AB.
M equals 1/2 of, M doesn't equal 1/2 of AB.
Sorry. Like AM equals half of AB.
Wouldn't that be sweet if our proving statement was just a two-step proof? That's not actually what a midpoint is.
I know what the definition is, but don't know how to define it. Sure.
I mean, what you said was right. That M is in the middle, right, of segment AB. So what does that mean? If M is in the middle, then what, Nathan?
AM equals
Okay, if M is in the middle, then AM is equal to MB. Okay? And this is going to be the definition of midpoint. Whenever you've got a vocab word in your given statement, define it. That should be your second step. Definition of what a midpoint is. All right, and so now we've got this equation here, AM equals MB. We want it to equal this. So let's write what we want it to equal here. AM equals 1/2 of AB. Okay. Let's write what we have. We have the AM. We're in good shape there, right? The left side of our equation, what we have, matches what we want. But we have to somehow write MB as 1/2 of AB. What do you think? Gino?
AM plus MB equals
AM plus MB equals AB. Okay, don't write this down yet. Let's see where Gino's headed with this first. So how does that help us?
we get the AB there.
We do get the AB there, right? And we added something to the left side of our equation here that wasn't there before. So we kind of rewrote that. We did introduce the AB. Now, what allows us to say that AM plus MB equals AB? Actually, like where Gino's heading here, so we will make this our step 3 here. But what allows us to say that AM plus MB equals AB? Alex? Oh my gosh. Why, Adam? Segment addition postulate. I was just about to say, it's almost like we're adding, segments together, right? Yeah, the segment addition postulate, like the first one that you learned. Going back to it, segment addition postulate. Okay? I look at our equation that we have now, and I look at the equation we want to have, and then MB, we got to get rid of that, because there's no MB in our final equation here. Okay, we're kind of done with this for now. We move past that. There's no MB in our final equation, so we have to get rid of that somehow. If you're looking to get rid of something, you either have to subtract it from both sides or divide it or whatever, right? Or you can replace it with something else. That's another option. Peter, what do you think?
AB minus MB equals AM.
AB minus M, but they still have the MB there, right? If we subtract MB, we're just moving over to the other side. So even though that is an option to remove something, we want it completely gone from the equation, out of the picture. It's not a part of our proving statement. So replacing it is going to be the better option here. Can we replace MB with anything? Take a look at what we know. What have we already established? Nathan?
Replace MB with AM.
We can replace MB with another AM, right? Step 2, we said AM is equal to MB. If we want to get rid of MB, we can replace it with something that's equivalent to it. So now we have AM plus AM equals AB because of substitution. we replaced it. Okay? Now we have AM plus AM equals AB. We want to get to AM equals half of AB. There's something we can do here with those AMs on that left side that probably is equivalent to the time that some of you go to bed at night. Blake?
Division?
Not yet. We're not multiplying by anything. We will though. Peter?
2 a.m.
2 a.m. Right? 1 a.m. plus 1 a.m. is 2 a.m. Okay? We have 2 a.m.s on the left side, right? So let's write it that way. 2 a.m. And our reason for that, you can write simplify or combine like terms. Either one's fine. But Blake offered up division earlier, and he's not wrong. Because we want to get to 1 a.m. equals half of AB. We currently have that 2 a.m.s equals an AB.
It's not your birthday today, is it?
No, I never used that computer.
Oh my God. I'm like, why is it there? There's the posting. Will you look at it and let me know?
Yeah, sure.
Okay.
Yep.
I'll send you the link.
The students are requesting another Packer fan, just for the record, so we'll have to add that as part of it.
Listen, if I can get another Johnny along, that's about.
No, you know. Okay, so Blake brought up division earlier. How's that coming to play now, Blake? If 2 a.m.s equal a whole AB, but we only want 1 a.m. to equal half of an AB?
If you divide by 2, you substitute.
Exactly. Our sixth step and final step, which is good because we're out of room here, is if 2 a.m.s equal a whole AB, then 1 a.m. would have to equal a half of an AB, which is the, make me look good, division property. Okay. Division property. Woo! There you go. Okay. Are you feeling better than you were Friday after the first one anyways? This is going to be a baby step process. Very rarely. See, where algebra and geometry differ is that many of you, for your entire math careers, when you've been doing elementary math or algebra, the teacher showed one example and you're like, got it, good, right? That's not what this is. Okay, it's very rarely are students able to become masters at proofs after 1, 2, or 3 examples. And that's why PO16 is a multi-day thing. If you're feeling better than you were after the first one on Friday, you're in a good spot. If you're not, my recommendation to you then is to go back and study all of these things. Okay? Know what you're looking for. Take my words of wisdom, right? If it's a vocab word, define it, introduce things to the party. Take those things in conjunction with these definitions, postulates, theorems, things like that. It's going to take preparation. It's going to take studying more differently than you did in algebra. All right? Okay. We're not going to do the top right one just for time issues here, but I would like to give you some practice from your book.
Yay!
So,
You want to do this one? Look at your phone right there.
No, I don't.
in your book, I would like you to do. Can I delete this? Anyone else need these notes before I read them? I suppose if you can always just watch the video. All right, there's no homework line, but we're going to make one here. On page 116, I would like you to do number 3, which is developing a proof.
That's it.
No, that's not it.
Actually, no, I didn't want it. That's good.
8 through 11. Those aren't full proofs. Those are just like a postulate theorem. It says name the theorem that goes along with this statement. So kind of like the quiz you took earlier today. So that's nothing too bad there. Number 21, which is also developing a proof. And then number 22, which they give you the reasons and the statements. You just have to put them in the correct order. Okay, so in nowhere here do you do a full proof start to finish on your own. Okay, we'll save that more for tomorrow and on Wednesday. What's that? I could. Okay. All right, homework for tomorrow. That is how you math.